Welcome back to part 2 of an introduction, operations on functions. Part 2 we're going to focus on the operation of composition of two functions. And we'll continue with some of the functions we looked at last time. F of x, 4x minus 1, g of x, 5 minus x, and then we're going to be adding in h of x, this polynomial, if you want to pause and jot those down. Let's move on. Example 1. Using functions f and h from this list. Let's create the function f composed with h. The outputs of f composed with h of x, by definition, are created with this last function h of x being the input. So we're going to record f evaluated at h of x. Now what does function f say to do? F of an input is 4 times that input minus 1. We need to record 4 times our input, and then we will subtract 1, where our input is the function h of x. I didn't leave much room, but it's the polynomial x squared plus 3x minus 2. Okay, now we might want to simplify, multiply through the parentheses. Since there's no exponent here, we can take 4 times x squared plus 4 times 3x. And then we multiply 4 times negative 2, and we can record that as minus 8, but we don't forget to subtract 1 here on the outside of the parentheses. And collecting like terms, we get the quadratic function 4x squared plus 12x minus 9. So the composition of these two functions, f composed with h, is a new polynomial. Notice that the leading term is 4 times x squared. Okay. Now let's continue this example and compare this function with the function h composed with f, where the two functions are listed in a different order. And we're going to see that composition is not commutative. And we're going to get a different answer if we change the order of the functions in the composition. Okay, for now, let me pull this down so you can see these functions again. And we're going to create h composed with f. By definition, that first function goes on the outside, and this last function listed is the input. Okay. Now h is a polynomial. It has 3 terms. H of x squares x, adds 3 times x, and then subtracts 2. So h of f of x will square f of x, add 3 times f of x, and then subtract 2. F of x was that linear function from before. So we're going to take 4x minus 1, the quantity squared, plus 3 times the quantity 4x minus 1, and then subtract 2. Okay. Sometimes it can be helpful to compare the polynomial input squared plus 3 times the input, take away 2, to the composition function squared plus 3 times the function minus 2. Okay, you might want to pause and do the FOIL and the distribution. The result of squaring this first term would be 16x squared minus 8x plus 1. The result of distribution would be a positive 12x minus 3. We still have the constant negative 2 at the end. And collecting like terms, I just see one quadratic term I need to be careful here and collect the linear terms. And it looks like I have three constants. 1 minus 5 minus 4. Okay. Okay, so comparing what happens when we change the order of composition. In general, we will get different functions. Not always, but almost always we will get different functions. Okay. Example 2. Let's do the same thing, but with different functions. Let's create the function g composed with h, and then like we did before, we'll demonstrate that composition is not commutative. Okay. To create the outputs of g composed with h, we'll write g composed of h with h of x. G is the linear function 5 minus x. So g composed with h is 5 minus h of x. Okay. Yeah. Remember what we're calculating, g of h of x. Okay. 5 minus the polynomial. When we remove the parentheses around the polynomial, we have to be careful because we're subtracting. So we will change the sign of all three terms. So rewriting, we get 5 minus x squared. We subtract 3x, and we end up subtracting a negative 2, or adding 2. Like terms, we have a constant which adds up to 7. And this can be a tidy way of writing down this polynomial, since the leading coefficient is negative. But we could write our terms in descending order and get an equivalent answer right here. This might be a good time to pause the tape. I want you to demonstrate that composition is not commutative. And just a hint, what that means is to go back, change the order of the functions, and show that this new function is not the same as the original. You might want to pause now. Okay, checking your answer. H composed with g of x, by definition, is h of g of x. Reminding ourselves how h was defined. It's the polynomial input squared plus 3 times the input, take away 2. But in our case, the input is the function g of x. So we want to take g of x squared plus 3 times g of x minus 2. Here's g of x. We need to record 5 minus x, the quantity squared, plus 3 times 5 minus x minus 2. You might want to pause to do the simplification. We're simplifying in this case so that we can compare with our previous answer. Okay, so to finish this example, we need to take 5 minus x times itself. 5 minus x times itself. We need to distribute the 3. We need to use FOIL. We will get 25 minus 10x plus x squared. We'll collect some like terms. I see that we're going to have a 13. We still have this linear term minus 3x, and then I'll put my minus 13. Running out of room, but we can do this. Final answer, x squared minus 13x plus 12. Okay. And clearly, this parabola, this quadratic function with the leading term 1x squared, is very different than our earlier quadratic opposite x squared. And we have demonstrated pretty clearly that G composed with H is different than H composed with G.